Since in this chapter we discuss mainly a case that the acceleration is a constant. Okay, so for this case there are three important cases, and we represent these three cases using the motion diagram here. We can see that the first case is a case where the acceleration is 0. Okay. When the acceleration is 0, see them. If we measure the position of an object, in this case it's a car, and the time difference for each measurement, okay, I mean the time difference here, delta t here, and delta t here are equal. And since there is no acceleration, so the motion moves with constant speed or constant velocity. And for the same time duration, the object will move with the same distance, or the displacement is equal for each time interval. Okay. And when you draw the motion diagram, you can see that the car are equal with space because the velocity is a constant, acceleration is 0. Okay. So that is the first case. For the second case, this is a case that the acceleration is constant. The acceleration is a constant. And the velocity and acceleration has the same direction. Okay. This is the second case. And for this case, we can see from the motion diagram that if we measure the position of the object and we use the same delta t, I mean that from this to this, the time is delta t, and from this point to this point is delta t, and from this point to this point is delta t, and from this point to this point is also delta t. Delta t is the same, but you can see that the distance delta x here and delta x here they are not equal. Okay. It is because we have the acceleration. We have a constant acceleration, and because the direction and of the acceleration and the velocity are the same, so we have that. Since you can see that for the same time interval, the distance is increasing, so it means that the average velocity, which is equal to the delta x over delta t, is increasing. Okay. So this is a consequence that the acceleration are in the same direction with the velocity. Okay. In this case, the acceleration and the velocity have positive direction. Okay. So the third case, for the third case, you can see that. Okay. Again, we still have the constant acceleration, but now we have that V and A have the opposite direction, have the opposite direction. Okay. So I think you can guess what will happen in this case. You can see that for the same time interval, here we measure the position of the car between the same time interval, delta t, delta t, delta t, and delta t. Time interval is equal, but you can see that the displacement delta x delta x delta x and delta x, you can see that delta x is decreasing. Okay, so it means that the average velocity which is equal to the delta x over delta t is decreasing. Okay, and this is because the acceleration and the velocity are in the opposite direction. Okay, in this case we have the positive velocity and negative acceleration, so the velocity will decrease, and we have this kind of motion diagram So you can see that drawing the motion diagram can give you the picture, or give you visualize, to make you visualize the motion, to give you the picture or the visual information of the motion. So sometimes this kind of representation is very useful. And for those example, is an example when the acceleration is constant, and this appears in many problems. So this is very useful when we use it as a model to analyze the motion of